Dear students, with a smile, with a positive note, welcome to Arith. Today we'll start our chemistry class. Before I start my class, I just want to say something for you. First of all, always work hard in silence. Let success be your noise. And second thing, there are two things needed for an entrance. First is about your focus and second about your calmness. Always be calm. हम में से बहुत से स्टूडेंट हैं सोचते हैं कि we have not that much of talent, I haven't that much of talent, हमारे पास उतना जैसा टैलेंट नहीं है, बहुत सारे चीजें आता है दिमाग में. I just want to say one thing that मैं भी आप लोगों के पास एक ही तरीका का टैलेंट नहीं हूँ, लेकिन you people have equal opportunities. You people have equal opportunities. All of us don't have equal talent, but all people have equal opportunities. You people have equal opportunities, and that opportunity is called entrance. You have to face this opportunity. You have to utilize this opportunity. You have to enjoy this opportunity. Definitely you can crack. Definitely that opportunity tends to towards your success. So just keep smiling. Work hard with the smartness. Smart work is necessary nowadays, and overcome your fear. Definitely you can crack. जो भी अपॉर्चुनिटी हमारे पास है, बहुत सारे एंट्रांस है. दैट अपॉर्चुनिटी आर कॉल्ड एंट्रांसेस फॉर यू. जो भी एंट्रांसेस है, वी आर ट्राइंग. कैसे हम पाएंगे, कैसे उस पर हम अपना 100% देंगे, वो बहुत सारी चीजें इंपॉर्टेंट है. एंड आई जस्ट वांट टू गिव यू इंफॉर्मेशन दैट हम अभी ये जो संडे आ रहा है, नेक्स्ट संडे, वी आर कंडक्टिंग ऑब्जेक्टिव एग्जामिनेशन ऑल्सो. जो भी हम संडे आ रहे हैं वहां पे हम एग्जाम कंडक्ट करेंगे जो ऑब्जेक्टिव का. ठीक है. सो सिलेबस जो है हम यूट्यूब पे आपको और आरित जो टेलीग्राम लिख के वहां पे भी हम डाल देंगे. आई होप दिस इज योर फर्स्ट एग्जाम, सो प्लीज बी प्रिपेयर्ड फॉर दैट. वहां से आपको कॉन्फिडेंस मिलेगा बहुत ज्यादा कुछ करने के लिए. ठीक है. अगर मार्क आता है, मार्क इट डजेंट मैटर, बस आप अटेंड करो अच्छी तरह से, विथ लेवल अटेंड करना, बहुत सारे प्रिपेयर करके अटेंड करना. ठीक है. वो आपको कॉन्फिडेंस बूस्टअप के लिए बहुत ही फायदेमंद होगा. तो आई जस्ट वांट टू से दैट नेक्स्ट संडे वी आर गोइंग टू कंडक्टिंग एन ऑब्जेक्टिव एग्जाम. यू पीपल ट्राई फॉर दैट. वी ऑलरेडी सेंड यू द syllabus, okay, for this examination, that in chemistry what are the portions, for physics and for bios. You just prepared hard, okay, and also please have a more movement on our telegram link, the doubt clearing classes, okay. Some people are outstanding there, but I hope you all subscribe students, जितने भी आप लोग सब्सक्राइब किए हुए हो यूट्यूब पे, वो सब टेलीग्राम लिंक पे आप ऐड हो जाओ. जितना भी डाउट है वहां पे डिस्कस करने की कोशिश करो. फाइन. और जो भी हमारा वेब पेज को भी जो भी रजिस्टर किए वो भी ऐड हो जाओ. ठीक है. पढ़ाई करो अच्छी तरह से. डेफिनेटली वी कैन क्रैक. तो स्टार्ट करेंगे हमारा जो भी क्लासेस है आज. केमिस्ट्री कंसेप्ट हम स्टार्ट करेंगे डी ब्रोगिली से, उसके बाद हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल, उसके बाद आएंगे हम क्वांटम नंबर. ठीक है. चलो स्टार्ट करते हैं विथ ए स्माइल. So now we start our chemistry class. Today the content first of all about its de Broglie concept, second Heisenberg's uncertainty principle, and third of all that is quantum number. Fine. तो पहले हम शुरुआत करेंगे de Broglie का वेवलेंथ से. अच्छा, what de Broglie says, one thing I just want to focus about that. Based on this concept, the electron have dual nature. One is particle nature, another is wave nature. Already according to Bohr's theory that we observed that electrons behave as wave nature, also wave characteristics, fine, frequency, wave number, wavelength, like that. Based on this concept, electron behave as dual nature. One is wave nature, another is simply particle nature. Fine. Acha. Already we know that according to Planck's quantum theory, energy emitted or absorbed in form of packets, not in a continuous manner, it always in a discontinuous manner, and every packet with some kind of energy, that is called simply what? associated with fixed or quantized energy, and that packet is called quanta. In case of light, that is called photon. Fine. Okay. According to Planck's quantum theory, E equal to simply so according to Planck's quantum theory, E equal to h nu. Fine. H is the Planck's constant. E directly proportional to nu. Nu is the frequency. So E equal to h nu. H is the Planck's constant. Nu equal to c by lambda. So we got E equal to hc by lambda. Fine. C, you know that is the velocity of light, and lambda is about wavelength. According to Einstein equation, E equal to mc square. Why we put these two equations? That is according to wave characteristics. Fine. And that is according to particle characteristics. E equal to h nu. Fine. E directly proportional to nu. That energy is directly proportional to the frequency. That is about wave characteristics. Here E equal to mc square, mass and velocity. Fine. Okay. So about this particle nature. So simply both E are equal. So hc by lambda equal to mc square. Lambda equal to h by mc, or lambda equal to h by mv. You can take also velocity, no problem. Fine. So lambda equal to h by p, mv equal to p, that is momentum. That is de Broglie equation. Lambda equal to h by mc, or lambda equal to h by p. So we put two equations. First, Planck's quantum theory that assigns that the electron is wave-like nature. So its energy is associated with wave characteristic like frequency. E proportional to nu, E equal to h nu. H is the Planck's constant. And again another equation, we put that Einstein equation, E equal to mc square. That is about particle nature. Fine. Okay. Energy depends upon mass and velocity. That is E equal to mc square. Both energy definitely equal. So you can put that equations. That has simply mc square equal to hc by lambda, that is nu equal to c by lambda. So hc by lambda equal to mc square, lambda equal to h by mc, or lambda equal to h by mb, or lambda equal to h by p. P is called momentum, amount of motion contained in a body. That is about momentum. Fine. So this is about de Broglie's equation. Now Bohr's theory and de Broglie concept. Okay, already I told you these things. That is simply according to Bohr's theory, the angular momentum equal to simply mvr equal to nh by 2 pi. Fine. Already I proved that, okay, in previous sessions. So simply this is your wave. Okay, this is your wave in a circle. The wavelength equal to n lambda equal to 2 pi r. That is perimeter of this circle. Fine. Where lambda equal to h by mv, that is from de Broglie equations. So 2 pi r equal to nh by mv, mvr equal to nh by 2 pi. Thus angular momentum is integral multiple of h by 2 pi. N is variable for different orbits. Fine. So according to de Broglie, we can prove that the angular momentum of an electron in orbit according to Bohr's theory. Fine. So what de Broglie says, simply it is about dual nature. One is wave-like nature, and there is particle nature. And by putting these equations or values, lambda equal to h by mv, we can assign the angular momentum according to Bohr's theory of an electron in various orbits. Fine. So this is about de Broglie concept. Already we discussed Planck's quantum theory. Already we discussed simply Bohr's theory of angular momentum. We already defined these things. So this is about de Broglie wavelength. What is the de Broglie equation? You just remember one thing, that is lambda equal to h by mv. Just one thing you remember in this note, that lambda equal to h by mv, and it have dual nature. One is particle nature, another is wave-like nature. Fine. So now we discuss a problem about this de Broglie concept. What is the question? What is the wavelength? So to find wavelength, this is the question. Okay. What is the data of an electron if its mass is like that? So the mass is given here, 9.1 in 10 to the minus 31 kilo. That is about mass of electron, and its velocity is 1 by 10th of the velocity of light. So P equal to 1 by 10 into the velocity of light. That is about 3 into 10 to the right. Fine. So the velocity is all about 3 into 10 to the 7 meter by second. Fine. So we have mass, we have velocity, and we have a question to find out the wavelength. And the value of h, you already know that the h equal to Planck's constant, that is about 6.6252 into 10 to the minus 34 joule second. Fine. That is about Planck's constant. So What is the wavelength? You just put the formula lambda equal to h by mv. H equal to, this is the value of Planck's constant, by m equal to 9.1 into 10 to the minus 31 kg, and that is our velocity. After the calculation, you got that 0.2426 into 10 to the minus 10 simply meter. This is the length of, this is the unit for wavelength. So we can find out that is about anything, lambda, mass, velocity, by putting this equation. That equation is about de Broglie concept equation, that lambda equal to h by mv or lambda equal to h by mc. H equal to Planck's constant, m equal to mass, and v equal to velocity. Fine. So here we can calculate the wavelength of an electron by given its mass and velocity also given. That is about 1/10 of the velocity of light, and you know that the value of h, that is about Planck's constant, that is the value. So put the formula simple numerically, both is simple so numerical, lambda equal to h by mv, and you put up this given data in the formula and got the answer. That is the answer to 0.2426 into 10 to the minus 10, and this is the unit for wavelength, meter and cm, like that. Meter and cm, like that. Okay. So now we start our another concept, that is about Heisenberg's uncertainty principle. Fine. Please focus on that word, that is about uncertainty, not certain, not defined. Okay. So we just go to the statement. It is possible to measure simultaneously the exact position and the exact momentum of a body as an electron. That means of an electron. Fine. So we couldn't predict simultaneously the position and momentum of an electron simultaneously. आप एक चीज को फोकस करना, ठीक है. मैं अभी मोमेंटम पे हूँ, ठीक है, रनिंग पोजीशन में हूँ, आप भी एक रनिंग पोजीशन पे हो, तो आप मेरा एग्जैक्ट पोजीशन और मोमेंटम यू नेवर डिफाइंड परफेक्टली साइमल्टेनियसली व्हेन at which position I am there, you can't define these things because we both are in a momentum, both are in a running movement. Fine. So according to Heisenberg's uncertainty principle, इलेक्ट्रॉन का पोजीशन, एग्जैक्ट पोजीशन और मोमेंटम साइमल्टेनियसली प्रेडिक्ट नहीं हो सकता है, ठीक है. फाइन. सो वी कुडंट प्रेडिक्ट द पोजीशन एंड मोमेंटम एग्जैक्टली simultaneously of an electron. That is about Heisenberg's uncertainty. Okay. So this is the formula del x, that uncertainty according to position, and del p, that is uncertainty according to movement, is greater than, this is the equation for Heisenberg's uncertainty principle. You just remember this equation, that del x and del p, that is greater than or equal to h by 4 pi. H by 4 pi. Maybe you have a question that how that equation is formed. This is about quantum mechanics. Okay. So that is the experimental analysis. So according to quantum mechanics. Okay. After in higher degrees you define these things. Okay. And that is about del x p, del p equal to mv. So del x into del p. So this is about m. Okay. M is going there. Del x and del p greater than equal to h by 4 pi m. So this is about Heisenberg's uncertainty principle. आप इलेक्ट्रॉन का, you just how you define electron. Fine. There is a electron. You just put up a light. The electron moved. So you never predict exactly the position and momentum simultaneously. Simultaneously एक ही टाइम पे हम पोजीशन और मोमेंट, इलेक्ट्रॉन का एग्जैक्ट पोजीशन क्या है और मोमेंटम क्या है नहीं डिफाइन कर सकते. वेदर वी फोकस अबाउट पोजीशन और वेदर वी फोकस अबाउट मोमेंटम, बिकॉज ऑल आर इन रनिंग मूवमेंट. यू फॉलो a light, that electron ejected. Just remember one thing, that is about Heisenberg's uncertainty principle. It is impossible to measure or predict simultaneously the exact position and momentum of a body, of an electron or of an electron. Fine. And the uncertainty in measurement of position, that is about del x, and the uncertainty in measurement of momentum, that is about del p. So this is the Heisenberg's uncertainty equation, that is del x into del p is greater than or equal to h by 4 pi. Just remember one thing, whenever you do the problem about these basics, you just have a formula that del x and del p equal to h by 4 pi, not about greater than, when you do numericals about that. Okay. So you go to the numerical. The question is about the uncertainty in position. Okay, that is defined, and the velocity of a particle are 10 to the power 10 to the minus 10 m and 5.27 in 10 to the minus 24 meter by second. So this is given, that is about uncertainty in position and velocity of a particle. Fine. Calculate the mass of the particle. So you just put the Heisenberg's uncertainty principle formula, that is about del x. Okay, del x and del v because del x given, del b given, that is equal. Okay, I just told you that. Fine. Whenever do numerical about this concept, you just equate that equation taking del x and del p is equal to h by 4 pi. Yeah, del x and del b is equal to h by 4 pi m. So this is about the formula. M equal to h by del x and del b into 4 pi. Just putting the values. That is about the answer, 0.099 kg. Okay. Just remember one thing. Please always give the unit. Always give the unit. Okay. Always try to focus on the unit. So we first class we already discussed the unit conversion and the unit. So this is about Heisenberg's uncertainty principle. First of all, the de Broglie concept, that is have dual nature, wave and particle nature. What is the equation? Simply lambda equal to h by mc or lambda equal to h by mb. And this is about Heisenberg's uncertainty principle, that is position and momentum couldn't measure simultaneously of an electron. Equation del x and del p, that is greater than or equal to h by 4 pi. This is the experimental data, also defined by quantum mechanics. Okay, and this is about the numericals. Okay, whenever do a numerical, just remember one thing: is just del x and del p equal to h by 4 pi. We'll take like that. Okay. So here the numerical, the given data is just always in the numerical focus. What are the given things and what is the question? How we solve this question through the given data. These three things is just remember when you do a numerical. Fine. So this is about Heisenberg's uncertainty principle. Never predict. Okay, exactly position and momentum simultaneously of an electron. Just remember the formula del x into del p is greater than or equal to h by 4 pi. When you do numerical, that is about equal. Okay, fine. Just remember one thing about this concept. Okay, whenever the given data is like that, that uncertainty position is about 0. Okay, so the total equation not about 0. You just take that del x equals 0. Leave it that del b is greater than or equal to h by 4 pi m. And numerically you know that del b equal to h by 4 pi m. इस तरह से आप क्वेश्चन को सॉल्व करना है. ठीक है. If del x uncertainty position is 0 or uncertainty velocity about that velocity is about 0, just you think that is 0. You eliminate that and put the rest of this formula. Fine. If del x equals 0, that is the formula. If del b equals 0, del x is equal to h by 4 pi m. You just put like that in numerical. Okay, and definitely you get the answer. Okay, fine. Just remember one thing. If one of them is 0, you just eliminate that and rest of your formula. Fine. If del x is 0, you just eliminate that. The formula is now about del b is equal to h by 4 pi m. If del b equals 0, you eliminate this. Del x is equal to h by 4 pi m. Okay, fine. So now we turn to the topic that is about quantum number first. Okay, you already familiar with that term, that is about quantum number. आप सब इसके साथ बहुत ही familiar हो. ठीक है. Quantum number, I just want to say one thing, that what is quantum number, why it's required. It's about quantum number means simply address of an electron. Electron का address जो है, that is about quantum number, address of an electron. You know there are 4 quantum numbers, that is about principal quantum number, azimuthal, magnetic and spin. What about principal quantum number? Okay, for the principal quantum number, the symbol is like n. Fine. Okay, according to Bohr's theory, you know that electron moving in a circular path called orbit, there are infinite number of orbits. Okay, from that quantum number we signify or we define electron present at which orbit. If n equal to 1, that is about k cell, n equal to 2, that is about l cell, n equal to 3, that is about m, n equal to 4, that is about m cell, like that. So from that value we could define that electron present in which orbit or which cell, first cell, second cell, third cell, like that. So it defines the electron present which orbit or which cell. Fine. So this is about principal quantum number according to Bohr's theory. Okay. And the second one, that is about azimuthal quantum number. Actually, that is derived from Bohr-Sommerfeld theory. According to Bohr, that electron revolving in a circular path called orbit. But according to Sommerfeld, the electron revolve in an elliptical path. Fine. Elliptical path where major and minor axes are there. When the major and minor axes are same, that defines a circle in an ellipse. Fine. So that azimuthal quantum number that defines actually simply that is about cell, this is about subcell. So it defines subcells like S, P, D, F. S stands for sharp, P stands for principal, diffuse and fundamental. These are the subcells. So According to principal quantum number, that electron present in which cell or orbit. According to azimuthal quantum number, that signifies or defines electrons present in which subcell. Fine. The subcells are like SPDF, that is according to the value L. Simply just remember one thing, L equal to n minus 1. If L equal to 0, that is about S. If L equal to 1, that is about P. If L equal to 2, that is D, and L equal to 3, that is F. Fine. So from principal quantum number, you could predict the number of orbits. From azimuthal quantum number, you predict the simply subcells. This is about cell. This is about subcell. Fine. Third one, that is about magnetic quantum number. Okay. So now the third, that is about magnetic quantum number. Okay. You just remember one thing. I write here something, that is for S subcell, that is L equal to 0, for P L equal to 1, for D L equal to 2, and for F L equal to 3. And you know that L equal to n minus 1. What is about magnetic quantum number? It defines the number of orbitals. It defines the number of orbitals. Right? Okay, just remember one thing, that for S, that L equal to 0. I just give you information. If on Sunday you have an exam, objective exam, the full mark is about 45 marks. If let us take, okay, 45 marks. Today, what you got, that is about from 0 to 45. That is from minimum value to maximum value. Fine. So in the subcells, what are the how many orbitals are there? For S, that is about from minimum 0, so only one orbital in S subcell. Fine. For P, that is 1, so minus 1, 0, plus 1. So there are 3 orbitals. Okay. In P subcell. For D, that is about minus 2, minus 1, 0, plus 1, plus 2. That is about 5. And for F, that is about 7 orbitals. Okay. For P orbital, that is about Px, Py, and Pz. And for D, that is Dxy, Yz, Dzx, Dx square minus y square, and Dz square, like that. Okay. Already next session I discuss all the things. Okay. Today I just introduce about that quantum number. So this is about quantum number, that the number of orbitals in subcells. Fine. Okay. By enlarging their value from minimum to maximum value. Okay. And the last of that is spin quantum number. This is the probability of spin of an electron, definitely in 2 ways, that is about clockwise and anti-clockwise. So there are 2 spin quantum numbers, that is about plus half and minus half. Okay, you assign like that. So this is about quantum number, the address of an electron, in which orbit it defines, in which subcell it defines, in number of orbitals it defines, and the probability of spin that defines. Okay, this is about quantum number, the address of an electron. We discuss in next session, that is the shape of orbital, the number of orbitals. Okay, and nodes, angular nodes, radial nodes, the applications. Okay, how we do questions about this quantum number. So lot of questions are there. So today we discuss about simply de Broglie concept. Okay, the dual nature, electron have particle and wave nature, the equation lambda equal h by mv, by putting these 2 theories, that about Planck's quantum theory and Einstein's equation. One is according to wave characteristic, another according to particle nature, and define the de Broglie concept, that equal to lambda by h by mv. And second one, that is about Heisenberg's uncertainty principle. We couldn't find simultaneously the exact position and the movement of an electron. Okay, because all are in a running movement. Okay, so now del x equal to del b, that is about greater than equal to h by 4.5. And finally, about quantum number, the address of electron. There are the 4 quantum numbers. What it defines? That defines the number of orbit. Okay, the electron resides at which orbit? That defines electron resides at which subcell, and this is about the number of orbitals in subcell, and this is about the probability of spin. Okay, SPDF, Sharp principle, diffuse fundamental. The formula simply n equal to 1, k l ml, like that. For azimuthal, L equal to n minus 1. For magnetic, you know, for L equal to, for S equal to 1, for P equal to 3, that is about Px, Py, Pz. For D there are 5, and F for 7, like that. Okay, spin, that is about S equal to plus half and minus half. We discuss all totally in the next sessions about these quantum numbers, and also have some question. Okay, I send it to the PDF through our link. Also I request to all of you, please join our Telegram link. There is for a doubt clearing classes. Okay, definitely we clear your queries and clear your questions. So please add this group, and if the new users, please subscribe our channel and also join our web page, that is re.com. Okay, thank you.